In this section, we will study the edge computing, which is a very common and trending technology nowadays, and it is well deployed and used by the 5G. The second enabler offered by 5G technology is the edge computing. As we mentioned, the edge computing is a possibility for an operator or even a third party to execute the services like compute, storage, and associated switching and control functions close to the user equipment or the access point of attachment. This feature will help to reduce the end-to-end latency and the load on the transport network so that the 5G can provide the low and ultra-low latency performance targets. So the idea is clear. To support the different types of services, 5G offers hosted services closer to the end user to meet specific requirements like low latency, low bandwidth requirements. You should note also that the edge computing capability is supporting flexible user plane routing so that the user plane buses can be selected to improve the user experience or even balance the network load when a user equipment or IoT device changing its location during an active communication. We will see after in the network architecture part that to enable the edge computing feature, the 5G select a UPF or user plane function network element to be put close to the user equipment and execute the traffic steering from this UPF to the local data network via an interface called N6 interface. One of the fundamental concepts and features in the design of the 5G system is user and the control plane separation in the 5G core network, which is called CUPS. But also you should note that the CUPS was originally introduced in the 4G. Control network functions offer their services to other control network functions through a service-based interface, which is relying on HTTP transport, so that each network function allow other network functions, authorized of course, to access its services. The control plane and user plane separation is providing much flexibility to service providers so that they can deploy user plane functions in one or more locations, which is meeting the bandwidth and latency requirement of the different customers. For example, a service provider may have to deploy more instances of the user plane function near a video game center where several customers are playing online games. However, on the other hand, in a shopping district or beside a shopping mall, there will be several mobile users who would be browsing internet for checking the information about the stores and shopping deals. So, in such cases or in such locations, the control plane has to scale out to support the several customer sessions which are not requiring low latency. In this slide, we are explaining the concept of multi-access and connectivity in 5G. So the multi-connectivity is one of the fundamental enablers for the deployment of 5G and then for the deployment of the future network architecture. So nowadays, as we are using different types of networks, increasing the speed and reducing the latency can improve the user experience, and the reliable high-speed data rates is a good benefit also for the end user. But of course, this cannot depend on a single frequency band or even using a single standard connection. So The multi-connectivity will help to provide the best user experience for different services and applications, of course, such as providing high bandwidth, providing good network coverage, reliable mobility of low frequency, and accessible Wi-Fi resources. So practically, in the scenarios that requires both high bandwidth and continuity, a user requires multiple concurrent connections. He needs to have many connections at the same time, and hence data aggregation from multiple subscription points like the 5G, the LTE, and the Wi-Fi will be required at this time to fulfill all of the requirements of the consumer or the end user. And this is done through the possibility of having multi-access or multi-connectivity. So with this concept and with this capability of having multi-access and multi-connectivity for the 5G networks will utilize and integrate a mixture of shared spectrum and the different types of access networks to meet the customer capacity and the coverage needs and requirements. So this capability and the design of the 5G is putting it at the center of the heterogeneous network, which means that you are having a network which is connecting different mobiles or user equipments, servers, sensors, and objects, where the operating system and the protocols are different between all of those devices significantly. So this new role, unlike the previous generations, is putting the 5G and making the 5G at the center, because the 5G has been designed from the beginning to be a multi-access network. So, for example, you will have a 5G core network which can be accessed by the 5G new radio, the 4G Node B, and the Wi-Fi, or even the fixed broadband network. And here, a list of the references that you can try to visit in case you need to get more information and more details about the different topics that we are discussing throughout the course.